Hi there. In this video, we're going to create a program that finds the all prime numbers under a certain number, and it adds all the prime numbers together and gives us the sum of those prime numbers. So to do that, let's create an integer number and initialize it to 0. This variable is going to hold the number, the max number, and we're gonna go below that number and find all of the primes of that. So we're gonna ask to enter some number for that variable. Enter a number. We're gonna add end lines, and we're gonna prompt to enter it. So to find the prime numbers, let's create a separate function for that. Here we're gonna declare the function prototype, and let's just call it prime, and we're gonna send integer to that function, and let's call it integer x, and at the bottom we're gonna declare the function itself. So we'll just copy the name x, and let's start coding. As you might remember, prime number is a number that is divisible only by 1 and by itself. Number 1 by itself is not a prime number. So to do that, we'll have to use for loops. So if you look at the graph, you can see that we have two changing variables, x and y. Let's call them x and y. While x decreases, y value increases. So we're gonna code that using for loop. So we're gonna say for integer x equals, let's use I instead of x because we already declared that. So variable I is gonna be equal to the number that we're passing. So let's say if we're passing 100, I is gonna be 100, and y, while I is more than 0, we're gonna decrement I, and this is gonna loop until I will equal to 0. So on this function, before doing actual calculation, let's declare a variable to hold the sum, and we'll initialize it to 0. So for this function, I want to use bool, we'll call it not prime equals false. So whenever I see a prime, whenever I see that the number is multiple and if it's not a prime number, we're going to change this variable to true, so we know that the number is not a prime. So let's go to the next for loop. We're going to say integer j, and this one we're going to start from number 2 because number 1 is not a prime number. So we'll start from 2, and we'll say while j is less than I, j++. The reason I'm setting this to while j is less than I, after each iteration I gets less and less. So when we're looking for a prime number, we don't want to go over the I. So that's why the range of j is going to change as well. It's going to decrease. And on this line, we're going to say if, and inside of the if statement, we're going to say I modulus j equals 0. So what this if statement means is that if I modulus, let's say I is 60, and j is going to be all the numbers below 60, and we're going to divide 60 by every single number below 60. If our if statement evaluates to 0, that means 60 is not a prime number because there is a multiple of 60. For that reason, if this if statement evaluates to true, that means the number is not a prime number. So we're gonna say not prime equals true. And we already know that I is not a prime number, So we don't want to waste our time by dividing 60 by other numbers. If it's divisible by any number, it's already not a prime number, so we're gonna say j equals I. This way our loop is gonna exit right away if we find out that the number is not a prime number. And here we're gonna say if not prime equals false. This statement means after all iteration, if I number didn't evaluate it to I modulus j didn't evaluate to 0, our bool variable will stay at false. That means the number is a prime number, and if the number is prime, we're gonna add that prime number to our sum. So we're gonna say sum equals sum plus I, and let's display our sum. The sum is sum, and let's call the function. We're gonna say prime parentheses, and we're passing variable number. Let's build and run this. Alright, let's test it out. Let's enter 68. So as you can see, the sum of all prime numbers under 68 is 569. And let's actually display every prime number that is under a given number. We're gonna say, let's say prime, and we're gonna display number I, and let's add space between them, and let's add an end line. Let's run this. Let's enter the same number, 68. Alright, as you can see, it shows all the prime numbers that is under 68. Alright, thank you very much for watching.